In today's lesson, we are going to talk about the difference of perfect squares.
What is a perfect square?
A perfect square is a number that when you take the square root, you get an integer. We need to know the perfect squares up to 15. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Knowing these perfect squares will make your life a lot easier when you are trying to factor with difference of perfect squares.
Right now I want you to factor the following expression just like we have been using the X puzzle. Pause the video, and when you are finished, restart the video.
If you factored correctly, you should have gotten x plus 4 times x minus 4. Now, let me ask you this. Do I really need 0x in that equation, x squared plus 0x minus 16? I mean, do we ever write 0x? No, we don't, so let's pretend it's not even there. If 0x is no longer in my expression, I get x squared minus 16. When I factor, I still get x plus 4 times x minus 4. This is what we call a difference of perfect squares. Keep watching to find out how it works. The key here is that I'm talking about a difference of squares. What does that word difference mean? The word difference means subtract. My problem must be a subtraction problem in order for me to do the difference of perfect squares. If you look over here, I wrote down a squared minus b squared, and if you haven't, you need to. That's our basic form of a difference of perfect squares. What do you notice about the symbol? That's right, it's subtraction. So we can factor this using difference of perfect squares. Let's see what else we need to have to factor. The first thing is that I must have a binomial. In other words, I can only have two terms. If I have a trinomial, this is not going to work. It has to be a binomial. The next thing about my expression that I need is a and b are perfect squares. This is why we need to know our perfect squares. We have to make sure that those numbers are perfect squares, or this method of factoring will not work. The last thing we need to factor a difference of perfect squares is even exponents. Odd exponents, no good. Make sure you have all of this in your notes so you know exactly what you need to have to identify a difference of perfect squares.
Okay, I got it. How does it work?
Step 1. Set up your parentheses just like we get our final answer for factoring. In this case, because we are multiplying to get a negative, we need one to be a plus and one to be a minus, because a positive times a negative gives us that negative which is in the middle. Step 2. Take the square root of the first term and put it at the beginning of each parenthesis. So for our example, I'm going to take the square root of 81x squared. The square root of 81 is 9, and the square root of x squared is x. So a 9x goes at the beginning of each parenthesis. The last step is to take the square root of the second term and put it at the end of each parenthesis. The square root of 36 is 6, so a 6 goes at the end of my parenthesis. And there you have it. That is your difference of perfect squares factored. 9x plus 6 times 9x minus 6.
Alright, let's do one more example. X to the fourth minus 1. Factor using the difference of perfect squares.
First thing I need to do, set up my parentheses with a plus in the one and a minus in the other. Next thing is I need to take the square root of x to the fourth. The square root of x to the fourth is x squared, so that goes in the front of each. Then I take the square root of 1, which is 1, and that goes in the back of each. Unfortunately, we are not finished with this one because x squared minus 1 can be broken down. Again, it's another difference of perfect squares. So put up my parentheses with the minus and a plus. The square root of 1 is 1, that goes in the back, and the square root of x squared is x, that goes in the front. Lastly, bring down that x squared plus 1, and now you have factored completely. Now go try some of those difference of perfect squares on your own. Good luck.
created using Powtoon.